All right, exponential functions, guys. The easiest way to start it off is to look at this top number right here, that plus 3. That number every single time is going to tell you what your horizontal asymptote is. Okay, that's kind of your guideline. That's where you start. Exponential functions do not have vertical asymptotes. And again, on the test tomorrow, there will be a spot for that. Just put none. Don't leave it blank. But I'm not going to just not put VA there and just give away that it doesn't have one, because on the SOL they're not going to do that. They're going to make you come up with it. So type it into your calculator, which I've already done, and you can graph it, get an idea about what it looks like, and it's going over and down. So go to your table of values and plot whatever points that you can. Okay, it looks to me like I can plot. Those first few are pretty easy. 0, 2, which is right here. You didn't get that? I'll come back and check in a second. 1, 1. 2, negative 1. And 3, negative 5. Did you get it?
Yeah.
Oh, yeah. And then remember, when I have a horizontal asymptote, I like to put that dashed line there. That way I know that I'm not going past that line, and make sure your graph, maybe follows it or is right on top of it, does not cross it, and then goes down and through those points. That is your exponential function. Okay, and usually the graph part people don't miss unless they type it in wrong. It's these 4 questions that are missed. Okay, the domain for these are always all real, every time. Put a little star next to it. It goes to the left forever, it goes to the right forever. But my range depends upon this horizontal asymptote. My graph is everything beneath that dotted line. That dotted line is located at 3. So it's all y values that are less than 3. Now guys, make sure you pick the right variable. If you say x less than 3, it's going to be wrong. Okay? If you just say less than 3, it's going to be wrong. I want to see what variable. The range always deals with y's. The domain always deals with x's. Just like your vertical asymptote also always deals with x's. All right, for these are rational expressions, guys. When they look like this, they have this plus 3 or minus 3 off the side. It's very similar to what that exponential function we just did. Okay, that plus 3 or whatever that number is, that tells you your horizontal asymptote. Okay, that's the only time that happens with rational expressions. Everything else you have to do a little bit differently. But with these, if it's got that number out there, that's it. Your vertical asymptote will always come from setting the denominator equal to 0 and solving, which you can usually do fairly easily. So my vertical asymptote is x equals negative 4. Once you get those two things, you want to draw your dotted lines. That way you have a guideline. So x equals negative 4 is this dotted line here. Y equals 3 is this dotted line right there. And then your calculator is going to take care of the rest of it for you. So get it typed in, which I already have done that. Graph it, get an idea about what it looks like. And you can tell your graph is shifted left and up. So it kind of follows your asymptotes there, but it's going to be in this top left and this bottom right. So go to your table of values, second graph, and find the error sign, which should be at that vertical asymptote of negative 4. And then plot a couple points on both sides. Okay, negative 5, 4 I can plot right here. And then I can also do negative 6 and 7 halves. That's 7 halves is 3.5. So left 6, up 3.5. It's about right there. Make sure I can see those points when you plot it. It's going to be tough to see because I'm using a Sharpie marker, but make sure I can see those 2 points. And then on the other side of it, you've got negative 3, 2. Then you've got negative 2 and 5 halves, which is like 2.5. Plot those 2 points, connect the dots with the curve, and there's your graph. The graph part's simple. It's the asymptotes and the domain and range you have to worry about. But what's easy about this is once you've got these 2 asymptotes done, your domain is all real, but your x never comes in contact with that vertical asymptote. So x cannot be negative 4. That's the only x value that it can't be. That's why it has an error sign in your calculator. Your range is the same thing. All real, but y cannot be equal to that horizontal dotted line, which is located at 3. All right, this one here, guys, a little bit different. We don't have this number added or subtracted off to the side. Okay, so we got to find the horizontal asymptote a tad bit different. The vertical asymptote is found the same way. Set the denominator equal to 0 and solve, and you get x equals 1. So that part's still the same. That'll always be the same. So draw that dotted line at x equals 1. Now here's the thing. With horizontal asymptotes, you have to look at the degrees of the numerator and the denominator. The degree is the highest exponent. Okay, the highest exponent on the numerator is 1, x to the first, and same thing on the bottom, x to the first. If that's the case, whether it's x squared over x squared, or x to the third over x to the third, you look at the leading coefficients, which in this case is 1 over 1. 1 over 1 reduces, of course, to just 1. Okay, had it been like 2x plus 3 over 1x minus 1, then it would be 2 over 1. But you look at the leading coefficients. Okay, that's how you find those. That's only if the degrees are the same. Everything else is done in the calculator, just like before. So graph it, get an idea what it looks like. It should look the exact same as your last graph. It's got that same behavior. But go to your table of values, find your error sign, which should be located at 1. So scroll down until you find 1 or scroll up. Put it in the middle and plot a few points around it. I can plot -1, -1. I can plot 0, -3. That's right here. That'll be enough for that side. So an ugly line. And then do the same thing over here. 2, 5, and 3, 3. 2, 5, and 3, 3. There you go. And just like before, once you find the vertical and the horizontal for these, the domain and range is really simple. It's all real except x cannot be 1, and all real except y cannot be 1. Make sure that you put the appropriate variables, x for domain, y for range.